data source in Java database connectivity. Now we are considering data source. A data source is a Java object that implements the javax.sql.data source interface. The data sources offer a portable and vendor-independent method for creating JDBC connections. Data sources are factories that return JDBC connection to a database. J2EE applications use JNDI to look up data source objects. Here in JDBC architecture, type 1 drivers, you can see the data source here. Data source interact with JDBC API and JDBC or DBC bridge type 1 driver here. In type 2 drivers, you can see the data source here. Data source interacts with JDBC API and native API partly Java type 2 driver here. In type 3 drivers, you can see data source here. Data source interacts with JDBC API and Net Protocol or Java type 3 driver here. In type 4 drivers, you can see data source here. Data source interacts with JDBC API and native protocol all type 4 driver. Here you can see JDBC data source. What is JDBC data source? Here enable database connectivity to be managed by application server and are obtained by applications from the server's JNDI tree. Use dynamic pool of reusable database connections and the scope of data source, system or application. All JDBC configurations must conform to the new WebLogic-jdbc.xxd schema, for example. Here applications interacts with data source via JNDI lookup and get connection and perform SQL. Here the connections are inside pool, and pool and JDBC drivers are pool and JDBC driver are inside the data source, and data source interacts with DB. Here you can see how connection pooling works. And what is a connection pooling? A connection pool is a group of ready-to-use database connections associated with the data source. Connection pools are created at, for example, Oracle WebLogic Server Startup, etc. And here how connection pooling works. And benefits of connection pooling. Following are some advantages of connection pooling. Connection time and overhead are saved by using existing database connection. It facilitates easier management because connection information is managed in one location. Number of connections to a database can be controlled. The DBMS can be changed without the application developer having to modify the underlying code. A connection pool allows an application to borrow DBMS connection. Here, application component JNDI and JDBC connection pools are inside managed server. Here, application interacts with the data source B here, data sources here, and components interacts with the data source here, and the data source A, data source B, and data source C are inside here JNDI. And here data source A interacts with JDBC connection pool here, and here data source B interacts with JDBC connection pool here, and here data source C interacts with JDBC connection pool here, and connections are inside JDBC connection pool here, and connections interacts with DBMS here. Here you can see how data source connection pooling is used. Here you can see client and data source and connection here. And here and the here JNDI and connection pools are inside the managed server. Here the step 1 client is connected to managed server via lookup data source. Here the connected to JNDI via lookup data source, and here JNDI is connected to client via return data source, step 2. And here step 3, data source is connected to connection pool via get connection method, and here step 4, connection pool is connected to data source via return connection, and here step 5, connection interacts with DBMS. Here you can see JDBC 3.0 connection pooling architecture. The JDBC 3.0 API provides a general framework with hooks to support connection pooling rather than specifying a particular connection pooling implementation. In this way, third-party vendors or users can implement the specific caching or pooling algorithms that best fit their needs. The JDBC 3.0 API specifies a connection event class and the following interfaces as the hooks for any connection pooling implementation. Connection pool data source, pooled connection event listener. This figure shows the general framework. This is JDBC 3.0 connection pooling architecture. JDBC vendor data source. A JDBC driver vendor must provide the class that implements standard connection pooling data source interface. This interface provides hooks that third-party vendors can use to implement pooling as a layer on top of their JDBC drivers. The connection pool data source interface act as a factory that create pool connection objects. The JDBC driver the JDBC JDBC driver vendor pool connection. A JDBC driver vendor must provide a class that implements the standard pool connection interface. This interface allows third-party vendors to implement the pooling on top of their JDBC drivers. A pool connection object acts as a factory that create connection objects. Pool connection object maintains the physical connection to the database, the connection object created by the pool connection object is simply a handle to the physical connection. Pooling vendor data source. The third party vendor must provide a class that implements the data source interface. This interface is the entry point that allows interaction with their pooling module. The pooling vendors class uses the JDBC driver's pool connection data source object to create pool connections that the pool manages. Pooling vendor connection cache. The JDBC 3.0 API does not specify the interfaces to be used between the data source object and the connection cache. The pooling vendor determines how these components will interact. Usually a connection cache module contains one or multiple classes. In this figure, the pooling vendor connection cache class is used as a simple way to convey this concept. The connection cache module should have a class that implements the standard connection event listener interface. The connection event listener interface received the connection event objects from the pooled connection objects when a connection closes or connection error occurs. When a connection created by the pool connection closes, when a connection created by the pool connection closes, the connection cache module returns the pooled returns the pool connection object to the cache. When an application make a connection by calling data source.get connection on a pooling vendor data source object, the pooling vendor data source object perform a lookup in the connection cache to determine if the pooled connection object is available. If one is available, it is used. If the pool connection object is not available, the JDBC driver's vendor's connection pool data source creates a new pool connection object. In either case, a pool connection object is made available. The pooling vendor data source object then invokes the pool connection get connection method to obtain a connection object, which it returns to the application to use as normal connection. Because the JDBC driver vendor implements the pool connection interface, the JDBC driver creates the connection object. However, this connection object is not physical connection as in the non-pooling case. The connection object is a handle to the physical connection maintained by the pool connection object. When the application closes the connection by calling connection.close method, the connection event is generated and is passed to a cache module. The cache module returns the pool connection object to the cache to be reused. If the application does not have access to the pool connection .close method, only the connection pooling module as part of its cleanup activity, issues the pool connection.close method to actually close the physical connection. Here the interface connection pool data source in package javax.sql in module java.sql. The factory for pool connection objects, an object that implements this interface will typically be registered with a naming service that is based on the Java naming and directory interface JNDI. Here the interface data source, a factory for connections to the physical data source that is that this data source object represents. An alternative to the driver manager facility, that a data source object is preferred means of getting a connection. An object that implements the data source interface will typically be registered with the naming service based on the Java naming and directory JNDI API. Interface pool connection in package javax.sql in module java.sql, an object that provides hooks for connection pool management. A pool connection object represents a physical connection to a data source. The connection can be recycled rather than being closed when an application is finished with it, thus reducing a number of connections that need to be made. Interface connection event listener, an object that registers to be notified of events generated by pool connection objects. Class connection event, an event object that provides information about the source of the connection event, connection related event. Connection event object are generated when an application closes a pool connection and when error occurs. Connection event object contains two kinds of information: the pool connection closed by the application. In the case of an error event, the SQL exception about to be thrown to the application. Interface pool connection, an object that represents hooks for connection pool management. A pool connection object represents a physical connection to a data source. The connection can be recycled rather than being closed when an application is finished with it, thus reducing the number of connections that need to be made. Interface connection in java.sql in package java.sql in module java.sql. The connection session with the specific database. SQL statement are executed and results are returned within the context of a connection. Here the JDBC. Here the JDBC driver vendor data source implements connection data pool data source. And here then connection data pool data source creates pool connection. Here the pooling vendor data source implements data source interface here. Pooling vendor data source use connection pool data source, and here the pooling vendor data source maintain pooling vendor connection cache. Pooling vendor connection cache is connected to can have many pool vendor data source, and pool vendor data source has one pooling and connection cache. And here pooling vendor data source is connected to a pool connection, and pooling vendor data source can have many pool connections, and one pool connection can have one pooling vendor connection cache. Here pooling vendor connection cache is connected to connection event listener. Here the pool connection is connected to connection event listener via plus event source and plus event listener. And here connection event listener is connected to connection event via use. Here the pool connection is connected to connection event via create, and here JDBC driver vendor pool connection implements pool connection, and here the pool connection is connected to connection via create. Here we are considering multi-data source configuration. Here the multi-data source configuring multi-data sources for use with here Oracle RAC, RAC. To connect WebLogic server to multiple Oracle RAC nodes using multi-data sources, first configure a generic data source for each Oracle RAC instance in your Oracle RAC cluster with the Oracle Thing driver. Then configure multi-data source using either algorithm for load balancing or algorithm for failover, and add generic data source to it. This figure shows the typical multi-data source configuration. You can use WebLogic Server Administration Console or any other means that you prefer to configure your domain, such as WebLogic scripting tool, WLSD or a JMX program. To use a database connection in this configuration, your application look up one multi-data source on JNDI tree and then request a connection. The multi-data source determines which generic data source to use to satisfy the connection request based on the algorithm type specified in the configuration. That is failover or load balancing. Here you can see a multi-data sources are in WebLogic servers. Here data sources are in multi-data source here. Here also data sources are in multi-data source here. Data source is connected to here rack. This data source is connected to rack node 1, RAC1, RAC node 1. Here this data source is connected to RAC node 1 here, and these two data sources are connected to RAC node 2 here. Here RAC nodes interacts with shared storage. Here RAC nodes are node 1 and node 2 interconnect. Here you can see the database connection life cycle. Every database read or write operation requires a connection. So let's see how database connection flow looks like. The flow goes like this. Step 1, the application data layer asks the data source for a database connection. Step 2, the data source will use the database driver to open a database connection. 3, the database connection is created, and the TCP socket is opened. For the application reads and writes to the database. 5 connection is no longer required, so it is closed. And 6, the connection is the 6, the socket is closed. You can easily reduce that opening and closing connections are quite you can easily deduce that opening or closing connections are quite an expensive operation. For example, PostgreSQL uses a separate OS process for every client connection, so high rate of opening or closing connections is going to put a strain on your database management system. Most obvious reasons for reusing a database connection would be reducing the application and database management system, OS IO overhead for creating or destroying a TCP connection, or other reason is reducing JVM object garbage. Here the interface data source in package javax.sql in module java.sql. The factory for connections to the physical data source that this data source object represent an alternative to the driver manager facility. A data source object is the preferred means of getting a connection. An object that implements the data source interface will typically be registered with the naming service based on the Java naming and directory JNDI API. Interface driver, the interface that every driver class must implement. Interface connection, a connection session with a specific database. SQL statements are executed and results are returned within the context of a connection. Class socket factory in package javax.net in module java.base. This class creates sockets. It may be subclassed by other factories which create particular subclasses of sockets and thus provide a general framework for the addition of public socket level functionality. Class socket in package java.net in module java.base. This class implements client sockets, also called sockets. A socket is an endpoint for communication between two machines. Here the application is connected to java.sql.data source via get connection, and data source is connected to driver via connect, and here the drive is connected to connection, and connection is connected to socket factory via create socket, and socket factory is connected to socket via new, and then socket is connected to the RDBMS. Then socket is connected to socket factory is connected to connection is connected to driver is connected to data source is connected to application, then application is connected to data source via close application is connected to connection via close, and connection is connected to socket via close, then socket is connected to the RDBMS. Here you can see pooling connection management flow. To understand why the pooling solution performs so well, we need to analyze the pooling connection management flow. Whenever a connection is required, the pooling data source will use the available connection pool to acquire a new connection. Pool will only create a new connection when there is no available ones left and the pool hasn't yet reached its maximum size. The pooling connection close method is going to return the connection to the pool instead of actually closing it. Here the interface data source in package javax.sql and in module javax.sql, a factory for connections to the physical data source that this data source object represent. Alternative to the driver managed facility, that a data source object is preferred means of getting a connection. An object that implements the data source interface will typically be registered with a naming service based on Java naming and directory JNDI API. Here the interface connection, the connection session with a specific database. SQL statements are executed, the results are returned within the context of connection. Here the application is connected to data source via get connection, and data source is connected to the pool via acquire, then pool is connected to the connection, then connection is connected to the pool, pool is connected to the data source, and data source is connected to the application, then application is connected to the connection via close, and here the connection is connected to the pool via release. Here you can see pooling connection management flow in a different way. Whenever a connection is requested, pool data source will use the available connection pool to acquire a new connection. The pool will only create a new connection when there is no available ones left in and pool hasn't yet reached the maximum size. The pooling connections close method is going to return the connection to the pool instead of actually closing it. Here the get connection is connected to acquirable. If acquirable is yes, it's acquired. Is connected to acquired, and if it is no, then check for max size, and if the max size is yes, then wait, and then wait is connected to the acquired, and if the max size is not, then increment pool size to the acquirable here, and here the if it is timeout, then retry. If the retry is no, then it's failure, and if yes, it's connected to the acquirable again, checking for acquirable. Here you can see life cycle of a data source object. Data source defined in java.sql package is an abstraction layer for Java database applications. Database applications may use JNDI context to find data source attributes that are configured on the deployment server. You can obtain data source objects in two ways, using JNDI without using JNDI. JNDI is an API accessing different kinds of naming and directory service. JNDI is not specific to a particular naming or directory service. It can be used to access many different kinds of system, including file systems, common, object request broker architecture, COBA, Java remote method invocation, RMI, and enterprise Java Beans, EJB, as well as directory services such as lightweight directory access protocol, LDAP, and a network information service, NIS. Although you can use JDBC to access a set of relational databases, you can use JNDI to access a set of naming and directory services. You will from a portability point of view, the obtaining data source interface using JNDI is more portable than not using JNDI. The data source interface provides an alternative to the driver manager class, making a connection to a data source using data source implementation is better for two important reasons. It makes code more portable and it makes code easier to maintain. A data source object represents a real-world data source. Depending on how it is implemented, the data source can be anything from a relational database to a spreadsheet or a file tabular format. When a data source object has been registered with the JNDI naming service, an application can retrieve it from naming service and use it to make a connection to the data source it represents. For example, JDK 1.4 documentation defines javax.sql.dataSource as follows: a factory for connection to the physical data source that this data source object represents, an alternative to the driver manager facility. A dataset object is a preferred means of getting a connection. An object that implements the data source interface will typically be registered with the naming service based on the JNDI API. Data source interface is implemented by a driver vendor. Three types of implementation exist. Basic implementation produces a standard connection object. Connection pooling implementation produces a connection object that will automatically participate in connection pooling. This implementation works with the middle tier connection pooling manager. Distributed transaction implementation produces a connection object that may be used for distributed transaction and almost always participates in connection pooling. This implementation works with the middle tier transaction manager and most always with the connection pooling manager. Data source object has properties that you can modify when necessary. It is, for example, if the data source moves a different server, you can change the property from the server. Benefits: the benefit is because the data source's properties can be changed. Any code accessing that data source does not need to be changed. A driver that is accessed via a data source object does not register itself with the driver manager facility. Rather, a data source object is retrieved through a lookup operation and then used to create a connection object. With the basic implementation, the connection obtained through a data source object is identical to the connection object obtained through a driver manager facility. This is according to structs. As a rule, you should always use a connection pool to access a database. The data source interface is a preferred way to implement the connection pool today. Many containers and database systems now bundle a data source implementation that you can use. Most often, the data source is made available through JNDI. The JNDI approach makes it easy for you to use business classes to access data source without worrying about who set it up. When connecting to a data source, a relational database such as MySQL or Oracle, using a data source object registered with the JNDI naming service rather than using the driver manager facility, and you get three benefits. It makes code more portable, it makes code easier to maintain, and you get benefit of connection pooling. For example, JDBC 2 introduced the data source interface that eliminates connection URLs and driver names in your Java applications. data source enables you to register using JNDI naming instances of the data source with unique name. Then the other application can retrieve the registered data source using unique name. A data source object provides a new method for JDBC client to obtain a DBMS connection represented as java.sql.connection. Data source object is usually created, deployed, that is registered and located, lookup operation, and managed separately from Java application that use it. This figure shows the life cycle of a data source object. In this figure, note that the directory and naming service item in JNDI enabled and can bind, register, and hold number of data source objects. Most databases can use CORBA based naming and directory services, but in order not to tie yourself with the specific implementation of JNDI, in this chapter here you see to use the file system based reference implementation of JNDI SPI driver from Javasoft. In real production applications, you should select a commercially available naming and directory service product, such as, for example, older Sun's directory server or Novell's directory server, and so on. One Java application 1, can create data source using some data source configuration from an XML file, a relational database, or a file-based system. Also, Java application 1 can register or bind and manage the created data source in registering a data source. You have to associate the data source with the unique key. Once the data source is registered, it is accessible to other applications such as application 2. The application 2 can get registered. The application 2 can get registered data sources using lookup method by providing the unique key. Some vendors such as BEA's WebLogic and IBM's WebSphere provide tools to deploying data source objects and then provide browsing lookup operations to get data source objects. Here you can see application 1 is connected to create the data source via create, and here created data source is connected to directory and naming service, and deployed data sources via deploy here, and it is connected to create data source via manage. Here the Java application 2 is connected to directory and naming service and deployed data source via lookup, and here the directory and naming service and deployed data sources are connected to the application 2 via data source. As an example, we can consider interface data source, a factory for connections to the physical data source that this data source object represents. An alternative to the driver manager facility, the data source object is the preferred means of getting a connection. An object that implements the data source interface will typically be registered with the naming service based on the Java naming and directory JNDI API. This is in the module java.sql and in the package java.sql. The data source interface is implemented by the driver vendor. There are 3 types of implementation. 1, basic implementation, produces a standard collection object. 2. Connection pooling implementation produces a connection object that will automatically participate in connection pooling. This implementation works with a middle tier connection pooling manager. 3. Distributed transaction implementation produces a connection object that may be used for distributed transactions and almost always participate in connection pooling. This implementation works with the middle tier transaction manager and almost always with the connection pooling manager. As an example, we can consider this code segment. After a basic data source implementation is deployed by the system administrator, it is ready for programmers to use. This means that a programmer can give a logical data source name that was bound to an instance of a data source class. The JNDI naming service will return an instance of that data source class. The method getConnection can then be called on that data source object to get the connection of that data source object to get the connection to the data source it represents. For example, a programmer might write this type of code here. First line of this code here, this line gets an initial context as the starting point for retrieving a data source object. When you supply the logical name JD here JDBC fast coffee DB at deployment time, on the when you supply the logical name JDBC / fast coffee DB to the method lookup, the method returns the data source object that the system administrator bound to the JDBC / fast coffee DB at deployment time. Because the return value of the method lookup is a Java object, we must cast it to the more specific data source type before assigning it to variable ds. The variable ds is a connection, is an instance of the class that implements the data source interface. Calling the method ds.getConnection produces the connection to the database. GetConnection method requires only the username and the password because the variable ds has the rest of the information necessary establishing the connection with the database here. And here the connection pool data source object are deployed. A programmer can use a data source object to get the pool connection here. The code for getting the pool connection is just like the code for getting non-pool connection. You can see here the variable ds represents a data source object that produces the pool connection to the database coffee break. You need to retrieve the data source object only once because you can use it to produce as many pool connections as needed. calling method getConnection on DS variable automatically produces the pool connection because the data source object that DS variable represent was configured to produce the pool connections. Connection pooling is generally transparent to the programmer. There are only two things you need to do when you are using pool connections. Use data source object rather than the driver manager to get a connection. In this code, DS is a data source object implemented and deployed so that it will create pool connections, and username and passwords are variables that represent the credentials of the user and user that has access to the database. And use finally statement to close pool connection. This finally block would appear after try catch block that applies the code in which pool connection was used. Yeah. Otherwise, an application using pool connection is identical to the application using regular connections. Only other thing an application programmer might notice when connection pooling is being done is that performance is better. Here you can see now we are considering some data source limits in database metadata. Some of the methods in this category are here. Another group of methods provides the limits imposed by a given data source. Some of the methods in this category are get max row size, get max statement length, get max table in select, get max connections, get max char literal length, get max columns in table. Methods in this group return the limit as an int. A return value of 0 means that there is no limit or limit is unknown. Now we are considering as an example, we are considering now data source properties in the data source interface in connections. Here setting and getting a data source property. Here the property property name server name, type string, and description database server name. The JDBC API defines a set of properties to identify and describe data source implementation. The actual set required for specific implementation depends on the type data source object, type of the data source object. That is whether it's a basic data source object, a connection pool data source object, or an XA data source object. The only property required for all data source implementation is description. Data source properties follow the convention specified for properties of Java Beans components in Java Beans 1.01 specification. Data source implementations may augment this set with implementation specific properties. If the new properties are added, they must be given names that do not conflict with the standard property names. Data source implementations must provide getter and setter methods for each property they support. These properties typically are initialized when the data source object is deployed, as in code example here, in which when the data source object implements data source interface. Here you can see getting and setting a data source property. Data source properties are not intended to be directly accessible by JDBC clients. This design is reinforced by defining the access methods on the implementation class rather than on the public data source interface used by applications. Furthermore, the object that the client manipulates can be a wrapper that only implements data source interface. The setter and getter inner methods for the properties need not be exposed to the client. Management tools that need to manipulate the properties of data source implementation can access those properties using introspection. Here you can see, now we are considering the JNDI API and application portability. Here registering a data source object with the JNDI based naming service. The Java and directory interface JNDI API provides a uniform way for application to access remote services over the network. This here we describe how it is used to register and access a JDBC data source object. See the JNDI specification for complete description of this interface. Using the JNDI API, application can access a data source object by specifying its logical name. A naming service using the JNDI API maps its logical name to a corresponding data source. This scheme greatly enhances portability because any of the data source properties such as port number or server name can be changed without impacting JDBC client code. In fact, the application can be redirected to a different underlying data source in a completely transparent fashion. This is particularly useful in the 3-tier environment where an application server hides the details of accessing different data sources. Here you can see this example illustrates the use of JNDI based naming service to deploy a new vendor data source object. Here the registering data source object with the JNDI based naming service. Note the Java EE components use a special convention for naming their data sources. Here the create a vendor data source object and set some properties. Use the JNDI API to register the new vendor data source object, reference the root JNDI naming context, and then bind the logical name JDBC/ACME-DB to a new vendor to the new vendor data source object. Now we are considering getting a connection with the data source object. Getting a connection object using data source object. Here the method connection get connection in interface data source in package java x.sql in module java.sql attempts to establish a connection with the data source that this data source object represents. Once the data source object has been registered with the JNDI naming service, an application can use it to obtain the connection to the physical data source that it represents, as is done in this code example. Here getting connection object using data source object. The data source implementation bound to the name JDBC/ACME-DB can be modified or replaced without affecting the application code. Here they get the initial JNDI naming context. Get data source object associated with the logical name JDBC/ACME-DB and use it to obtain the database connection. Now we are considering connection close in closing connection objects. An application calls the method connection.close to indicate that it has finished using a connection. An application calls the method connection.close to indicate that it has finished using a connection. All statement objects created from a given connection objects will be closed when the close method for connection object is called. Once the connection has been closed, any attempt to access any of its methods with the exception of close, is closed, or is valid methods will result in a SQL exception being thrown. Now we are considering connection pool data source and pool connection. Here we are considering the connection pool data source interface in connection pooling. The interface connection pool data source in package javax.sql in module java.sql, a factory for pool connection object. An object that implements this interface will typically be registered with the naming service that is based on the Java naming and directory interface JNDI. Typically, JDBC implements the connection pool data source interface, and the application server uses it to obtain pool connection objects. This the code example here shows the signatures for two versions of the get pool connection methods. Here the connection pool data source interface here. The pool connection objects represent the physical connection to a data source. The JDBC drivers implementation of pool connection encapsulate all its details of maintaining that connection. An application server caches and reuses pool connection object within its implementation of the data source interface. When a client calls the method data source dot get connection, the application server uses the physical pool connection object to obtain logical connection object. This code example shows the pool connection interface definition. This is pool connection interface. When application is finished using the connection, it closes the logical connection using the method connection dot close. This closes the logical connection but does not close the physical connection. Instead, the physical connection is returned to the pool so that it can be reused. Connection pooling is completely transparent to the client. The client obtains a pool connection using pool connection and uses it just the same way it obtained and uses a non-pool connection. When the connection.close is called when using connection pooling, any properties that were set by connection.set client info will be cleared. Now we are considering connection events. A connection event listener interface defines the following two methods which correspond to the two kinds of events that can occur on a pool connection object. The connection event listener, the interface connection event listener in package javax.sql in module java.sql, an object that registers to be notified of event generated by the pool connection object. Here the connection event listener interface defines the following two methods which correspond to the two kinds of events that can occur on a pool connection object. Connection closed, triggered when the logical connection object associated with this pool connection object is closed, that is the application called the method connection.close. Connection error occurred, triggered when a fatal error such as a server crashing causes the connection to be lost. Recall what recall that when an application calls the method connection.close, the underlying physical connection, the pool connection object, becomes available for reuse. Java Beans style events are used to notify the connection pool manager, the application server, that is pool connection object that can be recycled. In order to notify of an event pool connection object, the connection pool manager must implement connection event listener interface and then registered as a listener by pool connection object. The connection event listener interface defined these two methods which correspond to the two kinds of event that can occur in a pool connection. A connection pool manager registers itself as a listener for pool connection object using the pool connection.add connection event listener method. Typically, a connection pool manager registers itself connection event listener before returning a connection object to an application. The driver invokes the connection event listener methods connection close and connection error occurred when corresponding event occur. Both methods take connection event object as a parameter, which can be used to determine which pool connection object was closed or had an error. When the JDBC application closes its logical connection, the JDBC driver notifies the connection pool manager, the listener, by calling the listener's implementation of the method connection closed. At this point, the connection pool manager can return the pool connection object to the pool for reuse. When an error occurs, the JDBC driver notifies the listener by calling its connection error occurred method and then throws an SQL exception object to the application to notify it of an same error. In the event of the fatal error, the bad pool connection object is not returned to the pool. Instead, the connection pool manager calls the pool connection.close method on the pool connection object to close the physical connection. Now we are considering connection pooling in a three-tier environment. The following sequence of steps outline what happens when a JDBC client requests a connection from a data source object that implements the connection pooling. The client calls the data source.getConnection. Then the application server providing the data source implementation looks in its connection pool to see if there is a suitable pool connection object. The physical database connection available. Determining the suitability of a given pool connection object may include matching the client's user authentication information or application type, as well as using other implementation specific criteria. The lookup method and other methods associated with managing the connection pool are specific to the application server. Then if there are no suitable pool connection objects available, the application server calls the connection pool data source dot get pool connection method to get a new physical connection. The JDBC driver implementing connection pool data source create a new pool connection object and return it to the application server. Then regardless of whether the pool connection was retrieved from the pool or was newly created, the application server does the same internal bookkeeping to indicate that the physical connection is now in use. Then the application server calls the method pool connection dot get connection to get the logical connection object. This logical connection object is actually a handle to physical connection object, and it is this handle that is returned by the data source dot get connection method when connection pooling is in effect. The application server registers itself as a connection event listener by calling the method pool connection dot add connection event listener. This is done so that the application server will be notified when the pool connection object is available for reuse. Logical connection object is returned to the JDBC client, which uses the same connection API as the basic data source case. Note that the underlying pool connection object cannot be reused until the client calls the method connection.close. The connection pooling can also be implemented in two-tier environment where there is no application server. In this case, the JDBC driver provides the both implementation, the data source which is visible to the client, and underlying connection pool data source implementation. Now we are considering data source implementation and connection pooling. In basic data source implementation, the following are true. The data source.get connection method creates a new connection object that represents the physical connection and encapsulate all of the work to set up and manage that connection. The connection.close method shut down the physical connection and frees the associated resources. Aside from improved performance and scalability, the JDBC application should not see any difference between accessing a data source object that implements the connection pooling and one that does not. However, there are some important differences in the application server and the driver level implementation. A basic data source implementation, that is one that does not implement connection pooling, is typically provided by the JDBC driver vendor. In a basic now we are considering deployment. Here the deploying a connection pool data source. Deploying a connection pool data source object. The connection pool data source interface connection pool data source in package javax.sql in module java.sql factory for pool connection object. An object that implements the interface will typically be registered with the naming service that is based on the Java naming and directory interface JNDI. The deploying a data source object that implements connection pooling requires that the both client visible data source object and underlying connection pool data source object be registered with JNDI naming service. First step is to deploy a connection pool data source implementation as it is done in this code example. This is a deploying a connection pool data source object. Once this step is complete, the connection pool data source implementation is available as a foundation for client visible data source implementation. The data source implementation is deployed such that references to the connection pool data source implements as shown in here. Here the deploying data source object backed by a connection pool data source object. The data source object is now available for use in an application. Here the connection pool DS implements the connection pool data source interface, create an instance and set properties. Register the connection pool DS with JNDI using the logical name jdbc/pool/bookserver_pool. Here the pool data source implements the data source interface, create an instance and set properties. Reference the previously registered connection pool data source. Register the data source implementation with JNDI using the logical name jdbc/book server. Now we are considering reuse of statement by pool connections. The interface pool connection in package javax.sql in module java.sql, an object that provides hooks for connection pool management. A pool connection object represents a physical connection to a data source. The connection can be recycled rather than being closed when an application is finished with it, thus reducing the number of connections that need to be made. The JDBC specification provides support for the statement pooling. This feature, which allows an application to reuse the prepared statement object in much same way it can reuse the connection, is made available through a pool connection. As with the pool connection object itself, the prepared statement object can be reused in multiple logical connections in a transparent manner. Now we are considering statement events. The statement event listener interface defines the following two methods, which correspond to the kinds of events that can occur on a prepared statement object. The statement clause, triggered when the logical prepared statement object associated with this pool connection object is closed, that is an application called the method prepare statement.close. Statement error occurred, triggered when the JDBC driver determines that the prepared statement object is no longer valid. If the connection pool manager supports statement pooling for the prepared statement object, it must implement the statement event listener interface and then registered as a listener by the pool connection object. The statement event listener interface defines the following two methods, which correspond to the two kinds of event that can occur on a prepared statement objects. Connection pool manager registers itself as a listener for prepared statement object using pool connection add statement event listener method. Typically, a connection pool manager registers itself as a statement event listener before returning a prepared statement object to an application. The driver invokes the statement event listener methods and statement clause and statement error occurred when corresponding event occur. Both methods take statement object as a parameter, which can be used to determine the prepared statement object was closed or had an error. When the JDBC application closes its logical connection to a logical prepared statement, the JDBC driver notifies the connection pool manager, the listener, by calling listener's implementation of the method statement close. At this point, the connection pool manager can return the prepared statement object to the pool for reuse. When an error occurs that makes the prepared statement object invalid, the JDBC driver notifies the listener by calling statement error occurred method and then throws the SQL exception object to the application to notify the same error. Now we are considering connection pool data source properties. Setting connection pool configuration properties. Here the property name max statements, type int. Description, the total number of statements that the pool should keep open. 0 indicates that caching of statement is disabled. As with the data source interface, the JDBC API defines a set of properties that can be used to configure the behavior of connection pools. The property initial pool size int, the number of physical connection the pool should contain when it is created. Min pool size int, the number of physical connection the pool should keep available all times. 0 indicates that connection should be created as needed. Max pool size. Int the maximum number of physical connections that the pool should contain. 0 indicates no maximum size. Middle time. Int the number of seconds that the physical connection should maintain unused, should remain unused in the pool before the connection is closed. 0 indicates no limit. Property cycle. Int the interval in seconds that the pool should wait before enforcing the current policy defined by the values of the above connection pool properties. Connection pool configuration properties follow the convention specified for Java Beans components in the Bean specification. Connection pool vendors may choose to augment this set with the implementation specific properties. If so, the additional properties must be given the names that do not conflict with the standard property names. Like data source implementation, the connection pool data source implementations must provide getter and setter methods for each property they support. These properties are typically initialized when the connection pool data source object is deployed. The code example here illustrates setting properties in a vendor implementation of the connection pool data source interface. Here setting connection pool configuration properties. The properties on the connection pool data source object apply to the pool connection objects that it creates. An application server managing the pool of the pool connection objects uses these properties to determine how to manage its pool. Connection pool data source configuration properties are not intended to be directly accessible by JDBC clients. Management tools that need to manipulate the properties of the connection pool data source implementation can access those properties using introspection. Now we are considering XA data source and XA connection. Deploying a data source object backed by an XA data source object. The module, the interface XA data source in package javax.sql in module java.sql. The factory for XA connection object that is used internally. An object that implements the XA data source interface is typically registered with a naming service that uses the Java naming and directory service interface JNDI. Deploying an XA data source object is done in exactly the same manner as the connection pool data source objects. The two-step process includes deploying a XA data source, like XA data source object, and the application visible data source object as it is done in this code example. This is a deploying a data source object backed by XA data source object. Here the com.acme.jdbc.exe data source implements the exe data source interface. Create an instance and get and set properties. First register XADS with the JNDI naming service using the logical name jdbc/exe/inventory_exe. Next, register the overlying data source object for application access. com.acme.appserver.datasource is an implementation of data source interface. Create an instance and set properties. Reference the previous registered exe data source. Register the data source implementation with the JNDI naming service using the logical name jdbc/inventory. Exception example, we can consider SQL exception. If a database access error occurs in the method connection get connection in interface data source. As an error example, we can consider this error occurred in the environment with GZD and JDBC. The data source configuration failed WAX72091 connected to the process server 1 on node, etc.